Hi everyone, welcome to PlatformCon 2023. I'm Lionel Villard. I'm here with Alex Sovinsky to talk about environment and platform. The reason we want to talk about environment is because of serverless, and Alex is going to tell you in details why.
Let's take a look how we can make building applications inside companies easier with platform engineering, and in particular, what lessons we can apply from public cloud. As we know, public cloud can be very complex. Infrastructure can be very powerful. There are many options and become really hard to find what are the best options without becoming a cloud platform expert. Developers really want to be able to build application, and that's what serverless computing brings. It hides the complexity of underlying platform, but also makes it very easy to take advantage of auto-scaling or security that is provided by a particular cloud platform. If we take a look on how that is related to platform engineering, we can see that platform engineering is also one of the goals. It's also trying to hide complexity of underlying infrastructure. Actually, we can see that infrastructure is all over, or complexity, when we are looking on what are the problems with DevOps and what platform engineering is trying to solve. So what is platform, or what parts of the platform we can provide with a serverless approach and make it easier? Well, if we are looking on the platform, we can see that it is really about hiding complexity with different levels of abstractions, and it's all about providing the capabilities that then can be used by developers. What are those capabilities, and what happens if we are trying to look on a whole landscape? And in particular, there are a lot of technologies and services and APIs that can be used to build applications. You can think about it, applications is on the top, and then we have those underlying capabilities we want to use. And in between, we want to organize and provide the building blocks for our applications that are well tested, secure, and easy to put together. And what would be great to be able to have them available as part of that platform as environments in which we can run our applications. So what are those environments? We can think about that software development is really about life cycles. And in particular, we are moving as we are developing software from local environment, from our IDE or the place where we are testing and have inner development loop, to actually running continuous integration after we push our changes, putting into testing and staging, and eventually pushing into productions. The same code essentially go through all those environments, and all those environments should be also sharing a lot of underlying capabilities. So the differences between what you are running locally and what you are running production should not be very big. What would be very nice when we are thinking about those environments is that we can package reusable components that are well tested, they are secure and compliant with company policies, and they are maintained in platform way, but they can be also easily packaged, configured, and also evolve over time. So how we get there? Well, there are many tools available today to build necessary platforms and deploy necessary infrastructure. The approach we will be talking about today is related to Kubernetes, declarative way of building, where we say what we want to happen, but only on the very high level. So we declare what we need in our environments, and then let underlying controllers or other pieces of software to take care of reconciling differences, making sure that everything needed is actually implemented, or it fails. What would be the best approach for building such applications? And to have environments for them that are easily composed and then put together. So we can think that environment should be composed of some building blocks, and we would like really to have those building blocks to be very well tested. So when we start with something, we have a base environment. We describe or select from some list of well-tested base environment. And the list can be large or short, that does not really matter, but we do not really want to use environment or put anything into it that is really not easy or common or shared between different applications. For a particular application to work, we want to add necessary services or APIs or capabilities. And it should be really like component or packages that you install. Here we can have some abstractions like a workspace in which we want to run our application. And in those abstractions, we are saying we want to add Apache Kafka or serverless capabilities. And that is what Lionel will be talking about.
Great, thanks, Alec. Now, let me talk a bit about how concretely we can create and manage this environment.
All right, so here is an example of how we can use YAML to represent environments. And as Alec mentioned previously, environments are built on top of a platform, and in this case, this platform is called Secure and Compliant Platform. And this platform includes all the necessary tool and dependencies that to make sure that your application is going to be deployed on a secure and compliant platform, right? Then the second part of the environment is all the necessary dependency needed by your application, so all the service binding, and for instance, binding to a Kafka cluster, and also Knative service for deploying serverless functions. So in this particular case, we use the concept of workspace type that is coming from KCP to represent this environment. And the question is why we are using KCP. So let me explain the why and what is KCP. The first reason is really because KCP is based on Kubernetes. It has the same Kubernetes lack of declaring, defining your API, and in our case, this environment. And this is a nice feature, especially when you are familiar with Kubernetes. The second reason is because KCP, unlike Kubernetes, does not need a real cluster, expensive cluster, to actually deploy your YAML, so deploying environment. And this becomes relevant when your environment has dependency on serverless and only on serverless services like AWS Lambda, IBM Code Engine, or any serverless database, right? These are reasons why we decided to use KCP. So now, what is KCP? So KCP defined the concept of workspace, and you can think this as just being being in front of a Kubernetes cluster and have access to an admin access to your Kubernetes cluster, except that it's logical and it's very cheap. When you create a workspace in KCP, you can specify the type. And the advantage of specifying a type is as Alec mentioned, is to build your platform in layers, right? You start with something big and then you add layers and reduce the complexity on top of it by adding actually new layers, reducing the complexity in this case. And And it also allows you to package a set of API and configuration under, a name. You give a name to this workspace type. The third concept is about API. And this is important when your platform grows and you define your platform as a set of modules. So, like for instance, you have one workspace really dealing only about Apache Kafka, export the Kafka API to create topics, to create clusters, and then in another workspace, you can use API binding to import this API, and in your workspace, you can then create this cluster and this in this topic. And finally, another concept is that is being proposed is to add a hook when creating these bindings, so that, for instance, you can create a Kafka credential to connect to the cluster. All right, so I gave you just like an overview. If you want to have more details, I encourage you to go to the KCP website. So going back to the previous use case of an event-driven service application that depends on Kafka and Knative, you most likely want to define multiple environments and, in this case, multiple workspace type in the context of KCP. And in each of these environments, you're most likely going to use different components. Like, for instance, for the local environment, you might use Streamzy for Kafka. Whereas in the production environment, you might rely on managed service like the IBM Event Stream Kafka offering. But what matters here is like from an application perspective, what you're going to see is only the Kafka credential to connect to your cluster independently of what is running behind the scene. So how do you create this environment? As you can see, it's super easy. You just need one command line. This command line here create one workspace called mydev of type env local app. And by just doing this command, automatically everything will be set up in such a way that you can deploy your application in this environment. So let's say you have a Khan cluster running locally. By running this command, you will get a Kafka and a Knative system on your local machine ready for running your application. So this is fairly powerful.
So the question now is, how do you discover this environment? And that's where your IDP comes into play. So I'm not going to enter in too much detail, but it's easy to see that you can easily see the environment as part of the rest of the information of your service. And right there in the IDP, you can easily instantiate any environment with a single click or using the command line. All right. So we hope that we convince you that using KCP for managing environment, it makes the task of the software developer much easier. But as you can imagine, there's always a lot more to do. So we like to encourage you to join the KCP project, the KCP Edge project, and you'll find us there. And as well as the Janice project, which is the Red Hat sponsored Backstage offering. With that, thank you and enjoy the rest of PlatformCon.